Where did we come from? It is perhaps the most profound question a human being can ask. We look at our hands, we see our children, we gaze at the stars, and we wonder about the beginning of it all. For countless generations, this question has echoed through every culture and every corner of the world. Long before we had laboratories and microscopes, we had stories. These tales, passed from parent to child, sought to explain our presence on this planet. They are powerful narratives, rich with gods, spirits, and grand acts of creation. They have shaped civilizations and given meaning to human existence for millennia. In more recent times, a different way of seeking answers has emerged. This method is called science. It does not rely on ancient texts or divine revelation. Instead, it relies on evidence that can be seen, touched, and measured. Science asks for proof. It looks for clues buried in the earth, hidden in our very cells, and written in the light from distant stars. It is a slow, patient process of discovery, building a story piece by piece, tested and retested at every step. It is a story not of a single moment but of an immense and unfolding journey through deep time. We will explore both of these grand narratives, walking the landscapes of myth to understand their importance. For most of human history, the answer to our origin was not found in laboratories, but in creation stories. Before the age of science, narrative was our primary tool for understanding a vast and mysterious world. These myths, passed down through generations in nearly every culture, offer profound and resonant explanations for the ultimate questions. Where did we come from, and why are we here? They provided not just an answer, but a shared identity, a moral compass, and a sense of our place in the cosmos. Many of these foundational stories begin with a powerful supernatural being, a god, or a pantheon of gods. The act of creation is often portrayed as one of deliberate, intimate craftsmanship, with a divine hand that fashions humanity from the raw materials of the earth. The Abrahamic faiths tell of God forming the first man from dust and breathing life into him. In ancient Mesopotamia, the gods created humans from clay to serve them. From the Norse sagas, we hear of Odin and his brothers finding two lifeless trees on a seashore and gifting them breath, consciousness, and form, creating the first man and woman. In each case, these stories place humanity in a unique position, made with purpose. Whether as servants, companions, or stewards of creation, these narratives give us a defined role in the cosmic order, a reason for being that transcends mere existence. Another common thread speaks not of distant gods, but of ancestral beings, more than human, not quite divine. Some Native American traditions tell of emergence from the underworld. This is a narrative of becoming, a slow, deliberate journey from a primordial state, climbing through layers of reality to reach the surface world of light and air. Aboriginal Dreamtime stories describe spirit ancestors shaping the land, the animals, and the first people during a formative era. Similarly, Japanese Shinto myths tell of the divine couple Izanagi and Izanami, who churned the primordial ocean to form the islands of Japan, and from whom all life, spirits, and people descended. In these traditions, the landscape is not just a backdrop, it is a living testament to our origins, a sacred map of our ancestral journeys. Mountains, rivers, and stones are sacred parts of our story, and some origin stories look even further, to the sky. The Dogon cosmology, for example, speaks of visitors from a companion star to Sirius. This impulse to look upward is universal. From the intricate star charts of ancient civilizations to our modern myths of extraterrestrials shaping our species, we have always wondered if our story began not on this world, but among the stars. These tales, ancient and modern, are powerful expressions of our enduring cosmic curiosity, and our unending search for a place within the grand, universal narrative. Science approaches our origins from a different direction, assembling a story from countless observations. Life began in Earth's primordial oceans around 3.8 billion years ago. Simple, single-celled organisms emerged, the ancestors of every living thing, from the smallest bacterium to the largest whale. For billions of years, life remained relatively simple. Then complexity grew. Cells began to cooperate. Eventually, animals crawled from sea to land, giving rise to amphibians, reptiles, and mammals. We are part of this lineage, intertwined with all life. Among mammals, primates adapted to life in trees, grasping hands, forward-facing eyes, growing brains. The order includes lemurs, monkeys, and apes. Genetics and fossils show our lineage split from chimpanzees and bonobos about 6 to 8 million years ago in Africa. Gradually, populations diverged. Those who walked our path are called hominins, early human relatives. The central mechanism is evolution by natural selection. First described by Charles Darwin in 1859, it elegantly explains how life diversifies over geological time. The theory operates on three simple but powerful principles. First, individuals vary, providing the raw material for change. Second, these traits are heritable. And third, more are born than can survive, creating a struggle for existence where nature selects for advantages. Natural selection favors slight advantages that improve survival and reproduction. In our lineage, bipedalism conferred critical benefits on the savanna, seeing over tall grasses and freeing the hands to carry food. Across generations, this advantage was selected for, fixing upright walking as a hominin trait. If evolution is the theory, fossils are the primary evidence. But how do we date these snapshots of deep time? Scientists use stratigraphy, reading the layers of rock, and radiometric dating, which uses the decay of elements in volcanic layers as a precise geological clock. The Great Rift Valley preserved and exposed the bones of our ancestors. We find Lucy, an Australopithecus from 3.2 million years ago, with bipedal legs, but a small brain. Later, around 2.4 million years ago, comes Homo habilis, the handyman, whose fossils show a larger brain and are found with the first simple stone tools. The fossil record makes the pattern clear. Bipedalism came early, freeing the hands. Significant brain expansion and the dawn of tool use came much later, a pivotal step setting the stage for everything to follow. Stone tools are more than ancient implements, they are tangible artifacts of the evolving human mind. Each carefully shaped stone tells a story of intention and a growing intellect. The Oldowan toolkit, emerging 2.6 million years ago, delivered cutting edges sharper than a lion's tooth. These tools opened meat and marrow, transforming diets and fueling brain growth. About 1.7 million years ago, the Acheulean hand axe appeared. Symmetrical and standardized, it required foresight, a clear mental template, and many precise steps, showing a leap in patience and skill. Later, Neanderthals prepared cores to strike ideal flakes for spear points and scrapers. With Homo sapiens, innovation surged. Delicate needles for sewing, harpoons for fishing, and eventually the bow and arrow. But creativity wasn't limited to survival. We find the first stirrings of symbolic thought, perforated shells used as beads, and powerful art, deep within caves, suggesting a world of ritual and shared identity. Tool traditions reveal problem-solving, fine motor control, and cultural teaching. Technology mirrors a growing creative mind. In recent decades, DNA has become a revolutionary new source of evidence. It is the molecule carrying life's instructions, a shared library connecting all living things. Our DNA closely matches the great apes, about 98.8% shared with chimpanzees, our closest living relatives. Genetic data also reconstructs ancient migrations, confirming a recent African origin for modern humans. Scientists track specific genetic markers called haplogroups, passed down like ancestral breadcrumbs. By mapping these, we can trace the branching journeys our ancestors took across the globe. The greatest diversity in Africa fits where our species lived longest. And ancient DNA reveals a complex story of interaction, showing interbreeding with Neanderthals and Denisovans. Most non-African ancestry today includes small Neanderthal fractions, a tangible legacy of our interwoven past. Myths give who and why, purpose, identity, belonging. Their authority comes from tradition and faith. Science gives how, gradual, evidence-driven, self-correcting. New fossils and analyses can rewrite chapters overnight. Many hold both, science for mechanisms, tradition for meaning. Big questions remain: brain expansion, language origins, and undiscovered branches. The human family tree is bushy. We are still mapping it. The search connects us to life's tapestry and to one another. By comparing the stories people tell with the facts scientists find, we gain a richer perspective on who we are. Our quest has shaped our art, our religions, and our philosophies. Each discovery, ancient scroll or fossilized bone, turns a page in the human story. Let us explore with wonder and an open mind. Let us look at the world of myth and the world of science, and see what they tell us about our remarkable journey, the story of humanity. As we continue to dig, analyze, and question, we come closer to understanding how we came to be. We are a mosaic, shaped by time, shaped by kinship, shaped by ideas. The search itself is part of what makes us human. Our origins are not a single answer, but a conversation across ages, between myth and science, between past and future.